The thinking of theoretical physicists often seems very strange and paradoxical. For example, they have a deep fondness for contemplating unobservable entities, dark matter, the nabla vector, which cannot be visualized because its components are differential operators, the wave function, which no one has ever seen or measured with instruments, but which nonetheless successfully describes the laws of the microcosm. Interestingly, such a way of thinking nearly cost Soviet physicists their lives during Stalin's era. Quantum mechanics, like genetics, was declared an idealistic doctrine, and physicists were saved from execution only because the Soviet government urgently needed an atomic bomb. The ability to think unconventionally often manifests in great physicists at an early age. Once, Paul Dirac, one of the founders of quantum mechanics and a Nobel Prize laureate, participated in a mathematics competition as a student. Among the problems was the following. 3 fishermen caught some fish and went to sleep. One of them woke up and decided to go home. He divided the catch into 3 parts, but there was 1 extra fish, which he threw into the river. The other 2 fishermen did the same when they woke up, and each also had 1 extra fish. The question is, what is the smallest number of fish the fishermen could have had initially? The trivial solution to this problem is as follows. Obviously, each fisherman left 2/3 of the original number minus 1 fish for the next. Moreover, x3 minus 1 must be divisible by 3. From these equations, the answer is 25. For smaller numbers, the division would no longer result in whole numbers. However, Dirac overcame this constraint. He proposed a solution where the fishermen had fewer than 25 fish, specifically -2. Each fisherman discarded 1 fish, leaving -3, which they then divided equally. In the end, each fisherman went home carrying -1 fish under his arm. Interestingly, this solution loses the commutativity of the fisherman's actions. It is impossible to first divide -2 fish equally among the 3 and then discard the remainder. Instead, one must discard 1 fish first and only then divide by 3. Remarkably, such thinking not only leads to paradoxical solutions to problems, but also to great discoveries. In 1928, Dirac formulated an equation that predicted the existence of negative energy levels for free electrons. This implied that electrons could fall into negative energy levels, releasing energy, something that contradicted experimental evidence. Dirac then proposed that all negative energy levels were filled with a sea of unobservable electrons. However, with the application of external energy, an electron could transition from a negative level to a positive one, becoming an ordinary observable electron. The vacant spot, a hole, would have the mass of an electron but the opposite charge. Thus, Dirac predicted the creation of electron-positron pairs and the existence of the positron, which was experimentally discovered a few years later. Dirac also hypothesized the existence of magnetic monopoles, magnetic charges. Dirac's monopoles could provide crucial information about the structure and evolution of the universe. However, these hypothetical objects remain undiscovered. Amazingly, despite his genius, Dirac sometimes struggled to arrive at certain simple ideas on his own. He disliked attracting attention to himself and even wanted to decline the Nobel Prize awarded to him. However, Rutherford convinced him otherwise, remarking that refusing the prize would create even more noise.